Okay, this video is about solving one-step inequalities. Basically, you solve one-step inequalities just like you do one-step equations. Whatever you do to the left side, you need to do the right side. If it helps you to draw a line down the middle or down where the inequality sign is, just like you would for an equal sign, to keep it separated and to make sure you're doing the same thing to both sides, you can do that. Also, just like we did before, you need to do the inverse operation of whatever is happening to the variable in order to try to move the numbers that are attached to the variable away, and you can solve for the variable. So anyway, let's get started. And there's one exception though, and so I just wanted to make mention of that before we start, and then I'll show you an example of this in just a second. The one exception is when you're solving an inequality, if you multiply or divide by a negative number, then you need to flip the sign of the inequality. And I will show you what that means in just a second. Let's do a few practice problems with addition. Here we have x minus 5 is greater than or equal to 8. And so we know that if 5 is being subtracted from x minus 5, the opposite or the inverse, better word is inverse, the inverse operation of minus 5 would be to add 5. And then here again, if that helps to draw that line, we're going to do that to both sides. Okay, and 8 plus 5 is 13. And now we just bring down this sign. We don't change it at all. And negative 5 plus 5 is 0. So we can just bring down this x, and we get x is greater than or equal to 13. Okay, let's look at the next one. X plus 7 is less than 10. Okay, here we have x is being added to 7, so we can draw a line. We will subtract 7 from both sides. This is again subtraction, and nothing is different about subtraction. 7 minus 7 is 0, so we'll just bring down this x. We'll bring down our sign and leave it the same. And 10 minus 7 is 3, so we get the solution x is less than 3. Here's some multiplication for you. 5 times x is greater than or equal to 20. So if x is being multiplied by 5, we will divide both sides by 5. And we'll get 20 divided by 5 is 4. And 5 divided by 5 is cancels to x is greater than or equal to 4. And here's the next one. X is being divided by 7. Oops, I drew an equal sign there. Let's change that to, let's see, we can change that to less than or equal to. Okay, x divided by 7 is less than or equal to negative 3. Okay, now even though we have this negative 3 over here, what we're going to do is this 7 is positive. So x divided by positive 7, we're going to multiply both sides by positive 7, or 7 over 1 if you want to look at it that way. So that way these will cancel and we're left with x. If we were to have multiplied both sides by negative 7, we would get a negative x there, and that's not what we want. So again, we multiplied by a positive 7, so the sign does not change. Okay, it's still less than or equal to. And then negative 3 times 7 is negative 21. So x is less than or equal to negative 1. Again, we multiplied by a positive number, so we did not change the sign. Okay, now here we have an example where we have negative 2 is being multiplied by x. And this says greater than, and then greater than negative 10. And so in order to do the inverse operation of x times negative 2, we're going to divide both sides by a negative 2. Okay, now this is where that exception comes in. If we multiply or divide by a negative number, then we need to change the sign. So I'm going to go ahead and do this math here. I'm going to say negative 2 divided by negative 2 is x because the 2's cancel, right? And then negative 10 divided by negative 2 is a negative divided by negative is a positive 5. And now our rule was if we divide or multiply by a negative number, then the sign has to change. So instead of this sign here being greater than, we're going to turn it around. You can see how the arrow is pointed in the other direction. And now our final solution is x is less than 5. Okay? Now last example here, x is being divided by negative 8. So the inverse operation of divided by negative 8 is multiply by negative 8. So we're going to multiply both sides by negative 8. Okay? And so negative 8 times negative 8 is cancels, so we're left with x by itself. And 11 times negative 8 is negative 88. Okay, and then since we, again here, multiplied by negative 8, we're going to change the sign to greater than. So x is greater than negative 88. All right, that was just a few examples. We'll get some more practice in class. Thank you for watching.